Hi there, Joe here, and today we're going to find the eigenvalues and eigenvectors of a 2x2 matrix. Now this video does assume that you do know the introductory concepts to matrices and linear algebra, so without further ado, let's get started. We'll begin with a sample matrix 2, 3, 4, 1 and plug that into our equation, the determinant of A minus lambda times the identity equals 0. We'll now need to multiply lambda times our 2x2 identity. Now we'll need to subtract these two matrices. Next, we'll have to take the determinant of this matrix, and that's done by multiplying the main diagonal minus the product of the off diagonal. That'll give us the following equation, and this is our characteristic equation. Next, we'll need to FOIL out these two terms. That'll be done by doing the first, the outer, the inner, and the last. After we simplify our math, we're left with the following equation. We'll now need to expand these terms. And we'll set them equal to 0, giving us lambda equals 5 and lambda equals -2. We now want to take our eigenvalues and plug them back into our original matrix for lambda. We'll begin with lambda equals 5. That leaves us with the matrix -3, 3, 4, -4. We can now solve for our eigenvectors. That can be achieved by taking this matrix and augmenting it with the 0 vector. Now I have to put it into Reduced Row Echelon Form. You can calculate that by hand or with a calculator. Now we'll want to solve for our pivot values, and we'll find that V1 is actually equal to V2. And V2 is a free variable. And when you factor out V2, you're left with the matrix 1, 1. And that's our first eigenvector. I went ahead and solved for our second eigenvector by plugging in -2 for lambda. And that's how you find eigenvectors and eigenvalues of a 2x2 matrix. I hope you learned something, study hard, and we'll see you next time.